we are going to build an application that allows you to summarize a YouTube video. And one of the tools that you are going to use is the Ollama tool, but you will also use Llama 3 model, LangChain and Gradio to build this. This is the output of today's code. You have a YouTube summarizers empowered by Llama 3 large language model. It starts with putting in the URL of the YouTube link that you want. Then you can get title, you can get description of that YouTube video, and then you click this button and you will get a transcription. You can see the full transcript here. I should just change it, but whatever. You will get a full transcript here, and you can also see an estimate token count of this. Estimate token counts of this transcript. And when you click summarize, this full transcript will be summarized by the LLM for you. This is the end of our today's journey. Let's start with the basic idea of the summarization task. So basically, you have a source that you want to summarize. It can be in many forms like text files, PDF files, Excel's, Words. It can even be in a form of URL, HTML format, even database, perhaps like data frames. You have a source and you want the LLM to summarize. When you have a source, you need to load the text in order to be ready for summarization. And when you load it up, you are forming the prompt. And this is one of the prompts that is possible for this task. The prompt says, summarize the following text, and then you put in what you have loaded to that prompt, and then you end the prompt with enter. This prompt is effectively will be understood by the LLM so that it will create a summary of the given text. This is the basic idea. You have source, you load it to a text, and you craft a final prompt with a text you want to summarize being embedded in there, and then you give this prompt to the LLM. Simple. But there are two main issues here. One of the issues is that there could be non-text elements in the files. For example, like images, embedded objects like audio files, graphs. So these elements, most of the LLMs cannot handle it off the bat unless people need to do some coding or manipulations. But usually the LLM will not handle non-text elements. So that's the first challenge. The second challenge is the text that you want to summarize can end up being too long, longer than the LLM's context length. Remember, the LLM context length is the maximum number of tokens that can fit into the LLM. If you have a longer than that, you cannot fit it. You will get an error. So if you think of it as human eating, context length of the LLMs is how big the mouth of a human is in order to eat and digest the food, right? So if you have something that you want to summarize and it's too long over the context length, what are you going to do? This is the second challenge. So in this video, we will provide a way to handle challenge number 2, where the context length is overflown or the text is being too long. The idea is this. You add a few more steps in between. Again, you have the text that you want to summarize, assuming that you have loaded into the memory already, and it is too long. What you can do is you break it into chunks. The green chunk is the first chunk, and you have a yellow chunk. That's the second chunk, and you can see that it's possible to have an overlap between chunks, adjacent chunks. This is to make sure or to encourage the model to at least understand what is happening before in the chunk before. So this is one of the parameters that you can adjust in your chunk splitting process. And then you can imagine that you have as many chunks as you need in order to cover the whole text, right? And for each chunk, you are going to craft its associated prompt. Similar to this type of prompt, but in this text placeholder, you only put in the chunk that you want to summarize here. And you provide that prompt, let's say prompt 1 to the large language model to summarize, and then you will get one summary, and then you get prompt 2 and summary 2, prompt 3 and summary 3, and so on. Now, the last step, by the way, this step is the map step. You map a chunk to its summary. And then the final one is the reduce step. Now you have a list of summaries, you just want to reduce it to one final summary. And this is the final prompt. Might not be exactly like this, you can customize your final prompt, but it's going to be in the light of combine the following separate summaries into a coherent summary for me, and you provide list of summaries until the end, right? And then you give this to the LLM, and then you will get the final summary. So this is how easy it is, but it can be a lot of coding if you want to do that yourself. Luckily, LangChain, a famous tool for building LLM applications, has a wrapper function called load summarize chain. Allows you to do this type of application, the summarization, especially when the context length is overflown. LangChain provides a tools to use this to do this in just a few lines of code. And this is an example over here. In this example, some functions are loaded properly, and the source is an URL. The text of the source is loaded into this document. And okay, then LangChain will say, I'm going to use Chat and OpenAI model GPT 3.5 Turbo as my language model, LLM. And this is it. You get a chain by calling load summarize chain, putting in the LLM and the chain type that you want. Now, there are three chain types. The first one is stuff. This is stuff. Stuff is when you stuff everything in one prompt. It's applicable to when the text you summarize is small enough to fit within the context length. Just the basics thing. Stuff everything in there. But if you know that the context length is overflown, you need to either use map reduce or refine. I'm going to leave refine type, chain type for you to discover, but it can be as simple as replacing stuff with map reduce chain. That's actually, instead of that presentation slide, you can also come to my blog to read over this again. I think I provide more information in text here. Well, I should start with why do we need summarization? So it has values because there are many use cases. For example, can summarize a report, a file documents if it's too long. You can summarize a customer chat. If the customer is chatting with your company, you want to summarize what is happening, what kind of action that your company should take, for example. If you are learning new things on YouTube all the time, and most of the video is very, very long, an hour at least, like this live video, for example, you can use this to summarize your YouTube video as well. That's a catch. As I mentioned, the LLM works, right now the LLMs that we are using is Llama 3, works in text already. So it's not going to summarize YouTube based on its video, but it's going to summarize YouTube based on its transcription. Anyway, another application similar to the YouTube video is summarize a very long podcast, given that you can get a transcript from it. Here you have a basic thing, you have potential issues and the map reduce approach here. That's it. One more thing, I showed previously that you can use chain.run. That was an old style. In the new update, the run function was encouraged to be replaced by the invoke function, and it's just as simple as replace run with invoke. Alright, now enough theory and presentation. Let's go to the coding. Here we go. Alright, so I have prepared this so that it's ready to run and produce a Gradio interface. But I can walk you through what is happening here. Oops, sorry guys, my eyes are getting itchy. Anyway, so we are loading whatever tools that we need. We are using PyTube library to get information from a YouTube URL link. Gradio is for building an interface. Request is for retrieving information via an URL. Is needed to help us, in this case, extract YouTube description from a given link. LangChain is going to help us in working with large language models, prepare prompts and pass the outputs for us. Token is a library that we are going to use to estimate the token counts that we need to process. All right, now that's the import. Now this section is the helper functions. This function, as the name says, it will get YouTube descriptions if I provide it with a URL link. I didn't write this myself. It's from Stack Overflow. Thank you very much for those who have provided this to the public. This is a YouTube video info. So given the YouTube URL link, what I will get out here is a title of that video and the description where I will call the previously mentioned function. This one is going to help me load a YouTube transcript into. So now I have a YouTube transcript as a source. I want to just load it so that I can be ready for the splitting steps, right? Now I'm using a tool from LangChain as well. LangChain has a tool called YouTube Loader, where you give it a URL and it will just extract the transcription for you. Play with it and you will see what it looks like. Now I need this I wrap it up so that I can display it in my Gradio interface. Nothing more than that. So that text splitter is going to, so the text splitter is handling this part, handling this splitting part. By the way, when I show you guys these colored chunks, it's just theoretical. It's not as rigorous as when you are going to use tools like recursive character text split or sentence splitter. So for those kind of technical details, you can read the documentation. But again, LangChain provides text splitter tools for us to use. And one of the way that I'm going to use is a recursive character text splitters, where I provide the chunk size, how big, or for this chunk, how many tokens do I need as a maximum. And then I can provide the number of overlaps between adjacent chunks. Now this one is, I give in the URL of the YouTube video that I want, then I'm going to get a transcript text as a text, and also how many tokens are in it. And eventually this is the punchline here. This function gets called when a summary button is clicked. So basically what it needs here, it takes an input URL, the YouTube URL. It has a temperature, chunk size, and an overlap size. So basically what is going to happen is that first a document URL, which is a source, is going to be loaded as text to summarize. Then the steps of chunking will come in using a text splitter. Now I get chunks. Then I define the language model I'm going to use, and thanks to Ollama running at the background, my LLM is sitting on my laptop, available at localhost port 11434 with this temperature that I can set to whatever number I want. Then I create a change using a helper function called load summarize change, and I want a map reduce process or approach. When I have my change, I can just say invoke it. I'll get an output and eventually an output text. That's very simple, right? You might see that there are so many functions, but most of them follow through the steps. Load the text from a source, split the text to LLM, define a change, and run it. And these functions will be coupled with the Gradio interface. I am going to provide this code on my GitHub, so don't worry, you don't need to copy and paste here. But when I run this code, it's going to create a user interface via Gradio, where all the buttons are placed according to my design, and you can have it a go. By the way, this is a Jupyter notebook. You can have a Gradio embedded, interface embedded here, but what I want to show you is actually here. So I prepare main.py, which can be run with the command line, and at the end of the code, demo.launch, I set share to be true, meaning I will get a link that I can send it to somewhere else. So no matter where it is in the world, with the internet of course, he or she or the user should be able to run this app. So let's get started. We just pull a terminal. All right, this one is, yes, I'm using the right environment so I can run, ta-da, not yet. So it's, if I want to do it locally, it's here. But if I want to send someone else this link, he or she will be able to run this. So let's actually use that one. Now I put in the mail, it's loading the interface. This is how it looks like. Now I have a default value, so just to show you quickly. So okay, I want to get the info. Takes a while, but what it's doing here is initializing whatever it needs to do to talk to YouTube server, get the description back, and populate this. To make sure that I'm not fooling you guys, here we go. Yes, this is the video. So this is I created. It's about using generative AI when I travel to Tokyo. It's my first time there, and what kind of helps I can get from generative AI when I travel. And this is the title. Check this out when you have time. So this is the title. Gen AI helped me travel in Tokyo. And the description is here. It starts with 3 examples and ends with sharp chat GPT. Oops, sorry guys, not this page. So here, start with 3 examples and ended with sharp chat GPT. So I was able to retrieve the title and retrieve the description of a YouTube channel correctly. Now, next one, I can get my transcription. Clicking this button will talk to the YouTube server again, get back the transcript, and process how many counts. Using TikTok how many token counts are there for this transcription. So here, this is a transcript from my YouTube video. Here we go. And then you are ready to summarize this transcript. Now, make sure that you note this. So I made it in such a way that you can change the font size and overlap size parameter easily, the temperature as well. But again, this is a summarization task. So typically you want to set the temperature as low as possible. Now, Llama 3 context length is about 8,000 if I remember correctly. So this one should be able to fit in one go with with this one prompt. But let's actually fake it out. Well, you don't have to fake it out. So let's say that chunk size is 2000. It's a no-brainer that will take one computation, right? One summarization task, and that's it, because this thing can fit into that. While it's being calculated, let me just prepare a second video, which is much longer. My channel, how to go right here. I am going to go to a very long, this is a very long live sections, which is almost 2 hours. So I copy that URL already. So while it's taking quite a while, remember I'm running this LLM locally on my laptop, and my laptop is an M1 laptop, so it might be able to calculate it, but quite some time. I forgot to show you that if you run Llama serve, not the app, you can actually see the computation that is happening in the background. Taking quite a long time, to be honest. So while it's being calculated, I can point out several improvements that we can do with this. The first thing is, okay, now it's just interrupted me. All right, sorry, I'll come back to the idea later, but this is a summary. A traveler uses Google's Gemini app to navigate Japan without speaking Japanese, correct? Relying on generative AI for local information. Part 1, yes, you can get, if you don't know anything about that particular region of the world, you can ask for culture, manners that you should do in the public or something else, or like areas you should avoid. You can get Gemini to help with recommendations about cafes and restaurants because it has integration with Google Maps. And lastly, translation. This is a little bit understatement. In my video, I actually mean that Gemini helps you understand from an image, right? If you go to somewhere and you see, I want to buy this product, but it's not in English at all, you can try to ask Gemini to explain that product by taking an image and ask it to explain it to you. And this is what I did. And it was quite helpful. I had a headache and I want to take some medicine, but I'm not sure which one I should take. And with some help from Gemini, I can find the medicine I wanted. Now, while the AI is helpful, it has limitations in understanding cultural nuances and providing information on low-resource languages like Japanese. Correct? That's what I said. The speaker concludes that while it can be a useful tool, human interaction and research are still necessary for a deeper understanding of place. That's right. At least for now, when internet or the LLMs haven't been able to do extensive search, do research on its own for low-resource languages, like Japanese language, for example. All right, so this is a short transcript where it fits into one go. Now, let's try another URL. This is a longer one. Let's get a title. How to hire Gen AI LLM tokenization plus tick token. And another topic is about build customer chatbot with agent LLM and RAG. This is correct. If you go back here and I'll get a transcription from it. Let's see. Wow, that's quite a lot. 14,000 tokens. Definitely overflowing the capability of Llama 3. At least in the version that I use is 8,000 chunk size. So I am going to say try your best to understand chunk size of 5,000. So this should be able to put me to have 4 chunks or 5 chunks depending on the overlap size. Let's say I want to keep an overlap of about 10% of the chunk size. And just to be fun, maybe increases temperature. Well, I'm not going to do that. I want to make sure that it works properly, so I keep the creativity part of the model low. So now I'm going to hit summarize buttons and it's going to power through different chunks, right? Creating summary for each chunks. And with all these sub-summaries, it's going to write a final summary for us. Now, while it's going to be doing its job for, I hope, not longer than 2 minutes, I can point out what can be improved upon. First one, this can be changed to accommodate many other things like upload a file, right? You can add a tab there where a tab can be YouTube link for one tab, another link can be PDF, another link can be Excel file, for example. And then this is just a source, right? A location of a source. For YouTube, it can be like this. For a file, it can be a place where you can upload a file or drop in a file. And this section can be anything like information related to that file or a sneak peek into that file. For YouTube, I can add another panel that display an image, a cover of that YouTube video. I can do that too. I can add comments if I have APIs to retrieve that kind of information. This is the easy part. This is file related. But for the summarized steps, you can have an improvement on a set of parameters that you can tweak in the algorithm, right? Now, I forced you to use Llama 3. Maybe you want to have a drop box to select the model that you want to for it to work on this summarization task. That's possible as well. Other parameters can be a port number. If you decided that you are going to change the default value of the port away from 11434, or you think it might be possible that one day you are using this port and the other day you're using another, you can have a box so that you allows the user to provide a target port and a model to load it up with. That's one of the way. What else you can do? Well, let me just go back to my code and then you can actually help me spot out what did I do. What can be done to improve on this tab right here. So pretty much if you hard code anything, then this can be improved, right? Yeah, that's what I said. You can find a way to make sure allows the user to select the model you want to use. For tick token as well, you might allow for users to select an encoder to help you estimate the right number of tokens. Right now you see, well, the tokenizer is for ChatGPT, for GPT-4, but my model is Llama 3. That's a mismatch. That's the reason why I said it's an estimate token count. You can improve this as well. You can have a user select what type of chain types they want to use. It could be a stuff chain type, map reduce or refine process or something like that. Another possibility is to calculate how many chunks there is. Before the user hit summarize buttons, maybe they want to know how many chunks do I get myself into. Do I split it too little? Like, do I have to compute like 1,000 chunks where 20 can suffice? So that's a design option you can do. And another thing is, and this is maybe a critical one. As you can see here, the summary is short, right? I talked about 2 hours on 3 different topics. To be honest, I'm not going to be happy with this amount of summarization. It's too little. No, maybe it doesn't have enough detail so that I can learn from it. Think about it. If this is going to be about summarizing a lecture video and then you get this much summary, there's no point. So that is a way for improvements on many level of summarization tasks. If you just want a few liners, this is it. But if you want to summarize succinct enough but also have details so that you can actually learn or pick up some specific information for it, then you need to optimize and customize this process. All right, just to make sure that I understand this correctly, I'm just going to read through this summary. The text appears to be a conversation between two AI models discussing. I'm not an AI, see? Their capabilities, strengths, potential application. It's a human discussing 2 AI models along its dimensions, including capability, strengths, potential application, and so on. So this is wrong. One model suggests creating a career development plan based on user goals and assessments. The conversation also touches on tokenization, natural language processing, NLP, using a customer chatbot for. This is correct. This is not. Now it refers to a human speaker, me. The speaker demonstrates the chatbot's capabilities, limitations, suggesting improvements to handle specific requests. Right. Well, I am requesting that this particular chatbot needs to be improved if you want to have a better summarization task. Anyway, so it's just the way it is. I use pre-made function from LangChain. I got a pre-made summary. So this lesson actually tells you summarization tasks can be easy and it can be detailed. If you want high quality summarization tasks based on your goal, you probably need to dig deeper and customize your steps. and it's not going to be that difficult, guys. You see the concepts here. It's just that what kind of prompt that you are going to ask it and how many layers you are willing to go through, and that, in theory, that's it. Don't forget to give us likes, leave your comments, share us to your friends, and also subscribe to our channels. We have YouTube, LinkedIn, TikTok, and Facebook.